Today's topic is solving quadratics by completing the square. You did a little bit with completing the square in algebra and a little bit more in geometry. And today we need to get really good at completing the square and use it often in Algebra 2. So here we go. We're going to start with the example, x squared minus 6x plus 2 equals 0. Well, first of all, when you're solving any quadratic, you should try to factor it, because factoring is the easiest and fastest way to solve. But when I look at this quadratic, 2 has no factors that will add up to negative 6, so it doesn't factor, and there are no common factors either. So I need something else. You do know about the quadratic formula. We will use the quadratic formula sometimes, and we'll review that later. However, completing the square is often easier than the quadratic formula once you learn the process, and there's far fewer places for mistakes. There's lots of room to make mistakes with the quadratic formula within that square root. Here, we don't have as many places to make mistakes. We'll also use completing the square to get graphs of parabolas and circles into standard form, so it's a process that we really need to know well. Here we go. So when we're solving a quadratic by completing the square, the first thing is a has to be equal to 1. My leading coefficient must be 1. And here it is, so we're in good shape. So I guess for step 1, we'll say check that a equals 1. And here it does. If it doesn't, we need to do something else first. For step 2, we need to get c out of the way. So in other words, we're going to move our c term over to the 0 side. So here we'll subtract 2 to get c out of the way. And we have x squared minus 6x equals negative 2. For step 3, we're going to make what I call the b list. So we're going to take our b term, negative 6, and jot it down off to the side. Then we're going to take half of that b value. Well, if b is negative 6, half of b is negative 3. And then we're going to square that half b value. So that negative 3 all squared is positive 9. The reason we do that is if we take this half b squared value and add it to both sides, the left side is now a perfect square trinomial. We've essentially completed the square. So for step 4, we add half b squared to both sides. And so we have x squared minus 6x plus 9 equals negative 2 plus 9. Now keep in mind, the first time I teach you anything, I show you each step very detailed. At some point you'll get to the point where you can skip little steps. Like you could do negative 2 plus 9 in your head and write down 7 right away. But it's good to write down every detailed step for a while until you get good at it and discover those patterns and make sure you're not going to make little mistakes along the way. So again, the reason we completed the square is that this side is now a perfect square trinomial. If I asked you to factor it, and I'm not going to, but if I did, you would get x minus 3 times x minus 3. Well, we can actually skip the factoring step and rewrite the left side as its perfect square trinomial. Now what goes in your perfect square trinomial is the half b term. Remember when I said if I made you factor, this would be x minus 3 times x minus 3. Notice that negative 3 was your half b term. So when we rewrite the left side as the perfect square trinomial, it's x and your half b term here minus 3 all squared. In that same step, I combine my right side now. So negative 2 plus 9 is 7. So for really the final step, step 6, I'll say we solve as usual. Because now we have something squared. We know how to undo squaring by square rooting, and we know that when we solve and use square rooting, we need 2 roots, so we'll plus or minus. So we'll undo this squared by square rooting and just be left with x minus 3. And because I'm square rooting this side, I also need to square root this side. So it's the plus or minus square root of 7. And now we just get x alone by adding 3 to both sides. So here x is 3 plus or minus the square root of 7. If you chose, you could write that as the positive or negative square root of 7 minus 3. Sorry, plus 3 at the end. But often people are messy and they make that square root sign big, and it looks like the 3 is under the square root as well. So it's standard math form and good math form to write your real number out front, then your plus or minus, and then your irrational number. Okay, make sure you have those steps and that example written down, and we'll do a few more. Okay, so here's example 2. We're going to solve x squared plus 4x plus 5 equals 0. So again, first we check that a is 1, and here it is. It is not factorable. There are no numbers that multiply to positive 5 and add up to negative 4 or positive 4. So we need to do something else, and here we'll complete the square. So a is 1, we can move to step 2. Step 2 is to get the c term alone. So here I'll subtract 5 from both sides. X squared plus 4x equals negative 5. My next step is to make the b list. b is positive 4, so half of b is positive 2, and half of b all squared is positive 4. From that b list, we add the half b squared to both sides. Now I have x squared plus 4x plus 4 equals negative 5 plus 4. My left side is now a perfect square trinomial. I'm going to write it that way. And in the parentheses goes my x, and the half b term, positive 2. I'll clean up the right side. Negative 5 plus 4 is negative 1. And now we solve as usual. We undo squaring by square rooting. I have x plus 2 equals the positive or negative square root of negative 1. Now, until about a week ago, or even a couple of days ago, we'd have to stop there because we have a negative under the square root. Now we know that that's just I. So I'll subtract 2 from both sides and get x equals negative 2 plus or minus the square root of negative 1 is I. No longer do we say no solution. Now we can solve anything. And that really is the process for completing the square. You want a to be 1, and notice in the last two problems my b term was even, which made the math really easy. Now, life's not always easy, and so sometimes our b term won't be even. You can deal with fractions, again, reviewing those steps. So here I have x squared minus 3x plus 1 equals 0. A is 1, we're in great shape. We're going to move the c term over. X squared minus 3x equals negative 1. I'll make my b list. Here b is negative 3. I take half of b. We do not want decimals. We want to leave these as fractions. You need to trust that fractions are your friends and that everything works itself out in the end. So when I take half of b, and b is odd, like negative 3, I leave it as a fraction. So I'm going to leave this as negative 3 over 2. Again, trust that things work out in the end. Do not use decimals. When I square negative 3 over 2, I square both parts. Negative 3 squared is 9. 2 squared is 4. Again, leave that as a fraction. Do not use decimals. You won't be able to continue with decimals and you'll get really confused. Fractions work themselves out. My next step is to add the half b squared term to both sides. So I have x squared minus 3x plus 9/4 equals negative 1 plus 9/4. Again, leave it alone. My left side, believe it or not, is now a perfect square trinomial. I would never ask you to factor this on your own, but now it is actually factorable, and we know that it's a perfect square trinomial because I've just completed the square, and within those parentheses goes x and my half b term, and in this case that's negative 3/2. So x minus 3/2 all squared is equal to negative 1 plus 9/4. Negative 1 is negative 4/4. Negative 4/4 plus 9/4 is 5/4. Of course, you may use your calculator for that if you need to. I solve as usual on doing squaring by square rooting. So I have x minus 3/2 equals positive or negative square root of 5/4. To get x alone, I add 3/2 to both sides. So I have x equals 3/2 plus or minus. Now, notice that your denominator is a perfect square. The square root of 4 is 2. It is the same denominator as the other fraction. That always happens. This is why you trust the fractions. This is why you do not change to decimal. The square root of 5 cannot be simplified, so that stays put. And you're done. X is 3/2 plus or minus the square root of 5/2. You can leave that just like that. If you would like, this is totally optional, you can rewrite this over one denominator. There's a common denominator of 2, and the numerator is 3 plus or minus the square root of 5. Some people like to do that because it reminds them of the kinds of results we get when we use the quadratic formula, and that's very true. You can leave this like this. I suggest it. Why do an extra step and maybe make a mistake? But again, if it makes you feel better, and of course math is consistent and you like a consistent looking answer, this works as well. Keep your common denominator and just show the combination of the tops. Okay, I want to get you started on one more because I don't want the video to be too long. And I'll let you try to finish it on your own. So our last example is 2x squared minus x minus 1 equals 0. So remember, our first step is that a has to be equal to 1. And we have a problem because it's not. When a is not equal to 1, we'll need to make it 1. And you have to think about how that happens. Well, in order to make my a value a 1 when it's currently 2, I would divide by 2. But you have to divide everything by 2. So I'll divide that a term by 2 to make it a 1, but I have to divide every single piece by 2. So once again, you're going to end up with fractions. It's okay. You're big kids. You can handle it, and you have technology to help you. So now I have x squared minus 1/2 x minus 1/2 equals 0. Now you can complete the steps for completing the square. So sometimes when you complete the square, you'll get nice rational numbers, no square roots. The reason it happened is that this problem was actually factorable. If we had paused and done a product sum, we could have saved ourselves all that fraction work. But again, it's very good practice for you to see that you can complete the square with fractions and with an a value that's not equal to 1. And sometimes you will get irrational answers. You just have to be careful, trust your math skills, and use your technology as needed. That's it. Have a great night.